Hello everyone, this is part 3 of the Alkane series, in which we're going to look at the substitution reaction of alkanes in more detail. Now this is only for IB students. Okay, so in the previous video we saw that to get the reaction started we need UV light to break the bond between two chlorine atoms. Okay, and to look into detail what happens here, with UV light, this covalent bond breaks homolytically. This process is called homolytic fission because you create two identical species. So the electrons that were in the covalent bond are shared equally once upon breaking. So we create two chlorine radicals. So a radical is a species with an unpaired electron. So this dot here that we see. So this is called homolytic fission. Okay. Now in IB you need to know the 3 steps of these mechanisms. So the first step is called initiation. And these steps are the steps that start from a non-radical species and create a radical species. So if we write what happened in the equation above, you have a Cl2 with UV light. So I forgot it on the top there. Creates two chlorine radicals. Now, the second step is called propagation, where you use a radical to create even more radicals. Now, there's a lot of steps that could occur here, but let's say we're trying to react with methane, to keep it simple, and to look at the mechanism, which is a higher level part. In standard level, you only need the equations, so I'm going to put both here. So what happens is this chlorine radical helps break this bond. So chlorine, let's say, steals a hydrogen, and this bond that has two electrons, one electron goes with hydrogen and the other electron stays with the methane molecule. Now is CH3 radical. So what you end up having is the following. And in an equation format, it would be CH4 plus Cl gives us CH3 dot for the radical plus HCl, of course. This is what you need to know for standard level. This is a propagation step. We have created more radicals. Okay, there's more propagation steps possible. Now I'm just going to focus on the equations. This methyl radical could react with another chlorine molecule to form chloromethane and create another chlorine radical, which could react again with methane and continue the cycle. Okay, so propagation keeps the cycle going, keeps the radicals formed. Now, the final step, logically, is called termination, when two radicals recombine to form a non-radical species. And there are, again, many examples of that. So you could have two chlorine radicals reacting, which is not very useful because we would come back to the start. Or if we want to make a halogenoalkane, we can have a chlorine radical plus the methyl radical to make chloromethane. And this was our goal, and to begin with, to substitute a hydrogen with a chlorine, to go from an alkane to a halogenoalkane. Of course, you could make different products. You could make ethane. You could react two methyl radicals to create ethane. This is one of the key features of radical mechanisms, that they are unpredictable and create a variety of products. Well, thank you all for listening. This has been free radical substitution of alkanes.